All right. Welcome to this like question of the day, like weekly roundup. And what we're going to do here is take the time to go through the questions that we had for this week, and we will just walk through solutions as presented by some of you, and we'll just see if there are like weird extensions and odd ways by which we can actually solve it. We have 4 questions. I'm going to try to time box it to 15 minutes each, and see how we actually get to how we actually get through this session. All right. So the very first question that we had was a very simple one, which is find the singlet. So you're given a sorted array which contains only integers, and every element appears twice, or every element appears in pairs, except for one element which only appears once. So find that single element that appears only once. Now, the most logical way of actually solving it, people have done different things, but one question which was there was that can I have multiple, like can I have more than 2 of a kind? So can I have like 4 2s, or can I have 5 3s and things like that? The answer is yes. You should actually support duplicate elements as well, right? So does anyone know what is the O of n time O of n space solution for this? Like what solution actually will take O of n time and O of n space?
I would say using the hash map, something like that.
Yep, you could use a hash map where you can actually go check and keep checking. So essentially, every time you find something unique, you put it in the hash map, and every time you find something that is already in the hash map, you just delete from hash map. If you just keep it that way, it is sort of O of n space, but not really, because essentially you are not using the hash map will never be full, right? Because you're deleting from the hash map, right? The other way of looking at it is to just count all the elements and the number of occurrences. So every element will actually have the number of times it appeared on the side, and you can do that. That will work fantastically. What about the O of 1 time and O of 1 space and O of n time? What about the solution?
Just go sequentially since it's a sorted list. Find out which is single element.
Okay. So the one thing is that what if it is not a sorted list? Would that still help? Would you be able to solve it? If it's not a sorted list, how would you do it in O of 1 space and O of n time when the elements in the entire list are, it's not even sorted, they could be random. You could have a 1 followed by a 5, followed by another 1, followed by another 5, and so on.
I would say XORing all the numbers. That would probably do both sorted and unsorted.
Yep. If it's unsorted, if the variation of this question was that it's unsorted, then the simplest thing you can do is actually go and just go XOR, just do a cumulative XOR of every number, right, with every number. So all duplicates will cancel out each other, and then what's left is the number that's a singleton, that's a singlet. So that will work. Again, this is not the question we solve, but these are different varieties and flavors of the question. Just trying to see if we can get to all of that. Will that work for duplicate items? Like what if you have like 4 4s? Will it work?
Yeah, it should work.
It should work. It should work for everything that's even numbered will get cancelled, right? If you have like 17 4s, then it'll remain. One of the 4s will remain. But if you have 16 4s, they'll all cancel out each other. So that's fantastic. Now let's come to the meat of it, right? The log n solution. How would you do it?
Yeah, I think binary search is the way to go, but I didn't get a chance to kind of fix that for the duplicate scenarios.
So can you explain the binary search solution, Manish?
Yeah, I mean, so you'd kind of go to the middle of the array and then try to find which side, either left side is unbalanced or the right side is unbalanced, depending upon the number of elements in the array. And then
how do you know that? How do you know that? Can you elaborate that?
Sure. Let me quickly go over my solution for that.
So let's take the example that we have here, right? The first one, the line 23. So you have 1, 2, 2, 9, 9, and 10, right? So what is the midpoint? The mid is 7 elements, say 3, 4, 5, 10, 10, 10, 2, 10. So there are 7 elements are there. So the mid is 1, 2, 3, 4. This is the midpoint, right? Correct? 3 elements to the left, 3 elements to the right. So what we do is that we jump to the midpoint. Now what you do is you're actually checking what is the ordinal value, or what is the position of this one. This is the 4th location, right? So what I'm saying, the condition that you'll have is something to the effect of is location even and left not equal to current.
Are you writing somewhere?
Yes, in the Etherpad, and you should. Oh, so I've pinged you a link, Anusha, in QotD,
Okay.
Which is the public Etherpad.
I was already there. Yeah, I'm here, but
I am on line 40. I am on line 40.
Okay. Yeah, I can see.
That was it. Okay, and right is equal to current. Uh-oh. Something just happened. Right. That's okay. So I'm saying if the current location is even and left is not equal to current and the right is equal to current, okay, then what does that mean? Then it means that your left half is broken, has the singlet. Correct? Is that so?
Can you can you say this part one more time? Right here. I'll show you. Right here.
Mm-hmm.
Yeah.
So what I'm saying is that line number 37 is where I am, and in line number 41 is where I have written the condition, right? So first thing you do is you just go to the midpoint. In the midpoint, in this case, there are 7 elements. So 7 elements is essentially, midpoint is the 4th element, correct? 0 based. So if the location is even, that is what the case is here, and if the left value is not equal to current, so 2 is not 9, and the right is equal to current, which means that it's shifted this way, which means left half has singlet. So far with me? Okay. And on the same note, if the location is even and the left is current and the right is not current, then the right half has a singlet. Correct?
Yep.
So far with me? Okay.
Yep.
In the same way, is location odd, you will be able to create similar pairs of statement. Now, what is the fun part of it here is that it doesn't matter if the location is even or odd. What happens if left equals current and right equals current? That's where the problem is, right? Right. That's the scenario that we are talking about with in the case where you have too many duplicates. So if I had, like, for example, if this was this, right? If you had this line number 47, if you had this kind of a scenario, then the middle point is is somewhere, let me just get another 9 just for the heck of it. So the middle point is somewhere here. And unfortunately, I don't know whether I need to go, I don't know whether I need to, I don't know whether the left half is the problem or the right half is the problem. So how would you solve this?
What I've done in my solution is, again, binary search for the same leftmost 4 and rightmost 4.
You don't have to necessarily do both.
Both is required.
You just have to find one side. Pick a side. Go for it. You don't have to find both. Okay. So the way this works is that what you're trying to do is you're trying to find out how far is this 4, right? So let's say you want to find out when is the next 4. So you will be able to find out that 4 is here. This is how many 4s that are there. Okay.
Okay.
So once you have come to this point, what it tells you is that now you can actually use this as your pivoting point, and you can figure out if right half is broken or not. Right?
Yeah, but what if left half is broken?
If left half is broken, then what you do is that you know how many 4s you have covered, right? How many 4s have you covered?
On the right side.
1, 2, 3, 4. Yeah. How many 4s did you now see? Make sure that that's even. So it's like 1, 2, 3, 4, 5, 6, 7 4s I've covered. So what I will have to do is that I'll just have to find the singlet on the left side between this point and the first point. That's it. Correct? If the number of 4s on the right had been even, then I would actually include this one as well and figure it out. I mean, it had been. Does that make sense?
Okay.
So what I'm trying to do is you just find one extreme. You don't have to do both extremes. You just have to go to the right or left. Pick one, but go to the right. And how do you find the extent of the 4? How do you find how far the 4 is?
Yeah, I'm again doing a binary search.
You do a binary search, and this is like the expanding scope binary search, right? Where you're doubling your space. So you would actually jump 1, then you jump 2, then you jump 4, then you jump 8, and so on. And
yes.
that way that way you are still in the log n space. And once you have found out that right extremity, and you know how many 4s are there, right? So now you look at that location, and if you know that the right half of that is a problem, then you're good to go. If the left half is a problem, then 4 could be a part of the problem. Correct? Is that right? So what you're trying to do is that you know that every element, like you know that everything to the right, 7, 8, and let's assume that the 9 was not the problem and 1 was the problem, right? If that was the case, then you know that 7 is not the problem, 8 is not the problem, 9 is not the problem. So what you do is you know how many 4s you had to jump. Correct?
Yes.
You just make sure that you either include the middle pivot or exclude the middle pivot, and make sure that this block is even. The block between 4, the number of 4s that you saw on the right, that has to be even numbered. So that way, that is not the problem. Now the problem is entirely on the left half of the pile, right?
Correct.
And that's about it. So this essentially turns out to be a little less than log n, but for all practical purposes, it's a log n operation. Okay. Neat solution. Actually, it's not an easy question. I am not really sure if this will be something that people will ask in interviews, but I like this. And the one interesting thing was that I think I saw this question in lead code, but they did not have the duplicate case. So the duplicate case was an extra fitting that I added on to it, and I like it. So actually, you still use the same concept and you continue with it. Any questions on this one? All right. So good.
So,
Let's keep time and go on.
I have a question. So in case of this duplicate, you're searching. It is not binary anymore, right? You're searching the right half as well as the left half.
You're not, but you're actually. That is correct. That is correct. Go on.
But if you find both the indices, you don't have to search both halves. You just have to search one half.
It works. It will work the same way. It will work out to be the same thing, right?
Yeah. Yes, it is.
Right. You're actually doing the same thing, whichever way you look at it.
Yeah. Okay.
Okay. All right. So super good. So moving on to the next one. So this one was essentially the Great Plains question, which is essentially an adaptation of the histogram problem that we've seen before. So the histogram problem is actually a one-dimensional space where it's a bar graph, where you're given the height is given, that's the bar graph, and now if you put water in it, how much water will be held, right? That is what you're trying to figure out. Okay, and it's a dynamic programming question, pretty straightforward. Now this is a variation of it where you're trying to figure out how much water will you store in a two-dimensional array where every point represents the height, and we are trying to like put a lot of water in it. So given the input example that we have with three threes, with all threes in the border and one, obviously 2 units of water will actually be stuck in the central location. So how did we actually go about attempting this? Go on, Tarun.
Okay, so what I did was basically I actually created 4 arrays, and for example, in this case we have a 3 by 3 array and one in the middle. So what I did in the first case, basically I took the first column and subtracted that with the rest of the columns. That was one case. So it was a left case, and then I did it for the next array with top and then right and then bottom, and after that basically I did O(n) square search on the arrays and figured out whatever is the minimum value in the 4 arrays. So that's how I got it.
Fair enough. So one of the fundamental things to think about here is to see how much water will actually stand in any column. If I take any point in the square, right, in the thing, right, how much water do you think will be there at most? The amount of water that will be there in location will actually be, if you look at the entire column and you look at the entire row, right, whatever is the lowest peak of as in whatever is the, you have to look at the it's essentially a peak conversation, right? So in the bar graph question, the way it used to work was that we'll have this is assuming this is the baseline, right? So you would have like 1 unit here and like 2 units here. Has anyone here not seen the bar graph question? Let me see if I can actually grab an image of that. So sure. So if you look at this image, right? So if you look at an image like this, if I this is not a good image. I need this to be trapping rainwater. There you go. Okay, so if you have like bar graph like this, how much water will actually get trapped in this one? So the idea here is that you are saying the water level that can be here is maximum of 3. So in this column you will end up storing 3 units of water. In the next column it's 3 units of water. In this column it's 1 unit of water. In this column it's 3 units of water, right? And obviously you won't store anything here. You will not be able to store anything here. So the height is actually determined by the maximum value that you have. Baseline. So far so good? So here you will have to do something equivalent, where what you're saying is that if this had been a 2, the amount of water that you can store is only 1 unit, because this is what will limit that, correct?
Yes.
Okay. Now here is actually a different question. So if I had 4 and 4 and 4, right? How much water do you think I can store? It is 2 units here, because still the height of the water level is 3. So in the place where it is 1, I can store 2 additional units, and the place where it is 2, I can store 1 additional unit, and that's how it works, right?
Yes.
Now which means that the height of water I can store in the location that is marked by 1 is actually driven by what is the best I can do horizontally, what is the best I can do vertically. But here is a problem that we have. The problem is that if this had been a 2, what do you think is the maximum amount of water I can store?
Shouldn't be 4?
No, it will be 1.
Oh yeah, because the first one has only 2, so it'll be
The
kind
first
of...
one can only go as tall as 2, because after it all the water will spill over, and all the water will spill over. So essentially, in the previous question, if you just had the bar graph, which was just 3, 1, 2, 4, right? The height of the water that can stand in that column is actually 3, primarily because it is limited by either 3 on the left or 4 on the right, and so it will be a height of 3, right? But in this question, what happens is that since there is another dimension to it, you will have to actually look at every individual element and try to see where it actually goes. So this is actually a little bit more harder question than the basic bar graph question. So it's like a much greater like spin to the standard question. Does that make sense?
Yeah.
So Tarun's answer is correct. Tarun's answer is correct in terms of how he solved it for the cube question. Not the cube thing. What is that thing called? The n square path that works. But in order for you to be more efficient, you need to use a dynamic programming piece.
Yeah, that is what I was thinking, kind of going over each dimension and seeing what's kind of the limit is in the outer, both the not the outer, but the leftmost, when you kind of walk through it.
Mm-hmm. Yep. Okay. So anyway, any thoughts on how you would do this?
One more idea I was thinking about was, but I didn't go that route, was kind of like invert the array. So right now we are thinking about depth, but kind of maybe invert it in a way that we just get the peaks, and that's how we get it. But I didn't go that route.
Yeah, that's just a way of looking at it. I don't think it won't make a difference based on. I mean, it will be the same question, but just in different coefficients. Okay. All right. So that is just a hint here. In terms of how you want to do this is, I mean, the easiest way to look at it is that take a step back and think of how did you actually arrive at the fact that why did you choose in the dynamic programming question, why did we choose to actually go pick the largest element, like for every element where I am, right? You go look at what is the largest value that I have on the right and what is the largest value I have in the left, and you pick the minimum of the two to determine how much water will stay where I am, right? But there the assumption is that since the water only flows in one direction, what is larger than 2 on the right would be larger than me, and that's okay. But now that you have another dimension to it, it makes it harder, because now you need to actually run the question saying for each point you have to actually figure out what is the maximum point. and it will end up being a somewhat of a recursive solution. Like you will end up doing a sort of a breadth first search on this one if you need to figure out how much water will actually stay in each location. And once you get a static equilibrium, you can say that now I have all the answers and you can go figure out. So every tile, you'll have to figure out how much water will stay there independently. You cannot just assume that it's going to be the same across the entire board. Does that make sense?
So, I mean, if you walk from left to right and pick like the minimum height or peak, so let's say in the first one, the minimum peak is 2. And then based upon that, we calculate and move rightward. And if we find on the outer edge, if we find something minimum than what we had earlier found, we'll kind of update the value based upon that.
I'll stop you here, right? The first row, you cannot have any water anyways because it's all zeros above it. So you know that you cannot have any water that's actually staying in the very first level. 3, 3, 2, 4, no water can stay. You know that. Okay, next is your question, which is now you're saying?
The 2 I found on the left, that 2 is the peak. And then based upon that, I will start calculating the units of water. So for example, for 3, it will be -1, which makes it overflow. So there we cannot retain any water over there. Then on 1, that means 2 minus 1, we can retain 1 unit of water there. The next 0, next -2. So far now only 1. And then similarly, we walk through using the highest peak what we had.
No. How did you determine that you're going to put only 1 unit of water for 1?
Because the lowest peak is 2 in the first row, and we subtract that each value.
That won't work. Like if this had been the situation, if I just changed it for you.
Oh, I see. Yeah. So it's kind of 2-dimensional. Okay.
It matters. It matters. I think you need to the concept here is that you need to think through how you want to capture this information, right? So the way this would work is that the first is the best height for this row is like the water height, right? That can be there in every location is essentially 3 based on what we said for this column. For this one, the water height is essentially 4. In this case, it won't actually be at an entire column. Need not be the same case. Like if you had a 5 base system, right? You could potentially have a system where it was like 3, 2, 3, 2, 3, in which case it's not just one height, right? Let me actually make it like 4, 1, 4 or something like that. Then the water height is essentially, you're saying it is 3, 3, 3, 4, 4, right? Or something like that. Water height doesn't matter here, water height doesn't matter here. Water height doesn't matter here. So it is actually the water height of 2 is that. If in a bar graph question, right, how do you determine that? So you need to solve this problem in both dimensions. And once you have solved it in both dimensions, you have to again go back and see if you've actually resulted in a lower height based on anything else. And then you have to go back and do the dependency fix. So in this case, the way I would have done it is if this had been a 2 and a 3, the way this works is the first column says 3, this one says 4, and then this one says 3, right? Lower of the 2, right? Vertically speaking, this one is a 3, this one is a 3, this one is a 2, and this one is a 3. Now, if I compare this square is the one that actually got lowered in intensity, which means that the water will flow out of here up to a height of 2. So this one actually will have a maximum height of 2. Does that make sense?
Yeah. Yeah, it's kind of hard to visualize the dimension. Maybe
Yeah.
I'll try
So
to solve it.
the way you have to think about this is like this. So you have to solve that bar graph question for each row independently first. Okay. Once you have solved it, for every cell that where water is going to stay, you'll have to mark the high water mark. So you will say 4 units of water will stay here, 3 units of water will stay here, and so on. You solve it in the horizontal plane first. Then you solve it in the verticals the same way. You repeat the same bar graph question in the vertical direction. Now that you've done it, you compare the heights of both. If the horizontal solution is the same as the vertical solution, you're fine. If the horizontal solution is actually different from the vertical solution, then you have to update it to the lower value.
That makes sense.
And recompute that row, essentially. And that may result in lowering something else, and that may result in lowering something else. So this is actually a harder problem than it looks.
Kind of more like
want to do it
backtracking also, sort of. Not backtracking, but
it is backtracking. You're actually going, it's like kind of you're looking at all the dependencies and you're going round and round the maze of sorts, right? This is a 3x3, 4x3 example, so it's not that complicated, but if you start taking like 10x10, 20x20, you will see a lot of dependencies, and you might actually see circuitous dependencies where like one is actually affecting something else, which is affecting something else, and then it keeps going round and round in multiple ways. So it is possible that it actually might end up that way. So that is if you want to do it the most optimal way. Now, if not, you can always use the n square combination, but I'm a little uncertain, the n cube route, but I'm a little uncertain if it actually will return the right result. Okay, so this is something for us to think about. This is not super. I really don't think these kind of questions will come in an interview. It doesn't make any sense. But still, it is probably worth having the concept and idea in your head so that you can think about how to use it. Any concerns about this question? All right, let's go to the next one. Tic-tac similar. So yeah, so what was the thought? Unfortunately, I didn't have too much time yesterday and day before yesterday to actually help with the solutioning. So I did not participate in the discussions. So did people end up getting the tic-tac similar one?
Yeah. So in this case, basically, I actually rotated the array and flattened it out and put it in the dictionary. And then I did it for the second board also and compared the pattern.
How did you rotate it? What do you mean by rotated?
So, for example, like in the first case, basically you just read it out. So starting from 0, 0, then 0, 1. So basically you read the whole thing and put it as a string. And then in the second case, basically you're reading from 0 column max and then towards the bottom. So, and in the third case, you are reading from NN to backwards. So, and in the fourth case, basically, you are reading from bottom to top. So, so basically, you're just changing the way you're reading, and then you're storing that in a string and flattening the whole string and storing it in a dictionary. So basically you have a pattern, and then the second board you read that in the same way from 0, 0, and then you compare that.
Okay. So just looking at the example I have placed in between lines 86 and 90, right? Or 92. Right. Do you think that these are identical or equivalent?
Yes.
What about you, Tarun?
That looks like a mirror image.
Yes, and are they equivalent?
Yeah, but not from the perspective of the way I rotated.
Precisely. So you have done what is the rotation part of it, which is what I had mentioned in the thing, right? I said that I didn't mention rotation as such. I just said that it doesn't matter which corner it is, and that could be because of rotation or it could be because of mirror image. You don't know.
Okay.
Correct? I didn't say that. So for all practical purposes, these two boards are identical, right? If the best move for you to do at this point is here, this corner, then the best move to do it will be this in the mirror image location. So they're identical boards for all practical purposes, right?
Mm-hmm.
Okay. So so how would, now that you know this, how would you reconsider your solution?
I have to take. So rather than like reading the whole array as one pattern, basically, then probably I'll go column by column and rows by rows and have those patterns stored.
Mm-hmm.
And then
Would that help? Would that help? Like, are you complicating it more than simplifying it? I'm just trying to see. Any other thoughts? What about you, Anusha? What do you think?
Check for all the mirror images. Check if the top row matches the bottom row and left row matches the right row, and again mirror diagonally both the diagonals.
Mm-hmm. If you actually look at the, I've just updated the lines 86 to 92, right? There are 4 boards right now. All the 4 boards are actually equivalent. Correct?
yeah.
Like the top left is the original. The top right is the vertical image. It's a flip horizontal, right? And the 90 to 92, the left one is actually a flip, is a vertical flip. And the one actually further right is actually both vertical and horizontal flip. Correct?
Yeah.
So what does that mean? So how many cases do you need to consider? So given a particular state, you need to take 3 different mirror images of it and compare, and on top of that, what else do you need to do? The 3 different rotations.
Yeah, rotations and mirrors.
So is that 6 combinations will you check, or are there more? Are there more? What do you think, Anisha?
This
So this is a rotation, right? 94 is a rotation of the first one, correct?
Yes.
Right? It's a rotation where I've done a clockwise 90-degree rotate, correct?
Yes.
Okay. So that's, and I can do 2 more rotations and it will probably look different. But do I need to do more?
No. You can take the outermost string and place it side by side and see if the other this string you get by taking just the outer elements in one sequence is same is a substring of the first sequence.
Sure. Well, let's figure out how to match it later, but let's figure out if all have we considered all the cases. So what about you, Tarun or Manish? What do you guys think? Are we 6 cases? Is that all? Is that all we need? Like 3 different rotations and 3 different mirror images. Are we done?
I'm just thinking.
Yeah. Take your time.
So it's the 3 different rotations are just 90-degree each, or will there be sort of
90 degrees. 45 degrees is not possible, right? In a tic-tac-toe, you will have to orthogonally rotate it anyways. It is a 3 by 3 grid. It has to remain 3 by 3. So you can't have weird 45-degree angles, right?
That's true. Yeah.
What about you, Tam? What do you think? What about Anisha? What about, go say one more time?
Mirror image you considered along one diagonal. Is the other diagonal also covered?
Try it out. Think of it. Like, I don't know, maybe draw it out and see if you, apart from, see, the only mirror image you can get is a horizontal flip or a vertical flip or both. I can't think of any other way of actually flipping. Right?
I think that looks right to me.
Okay. What about check line 94? Okay.
Mm-hmm.
What about this case? Is it the same?
It's not.
94 right hand side, is that the same as 94 left hand side? Is it equivalent?
This is like rotate and the flip. Rotate plus.
Yeah.
Hmm.
Is it, and it's not a case that you have considered so far, correct?
Yeah.
Yeah.
So essentially, what you need to do is for each of the 3 different rotations, you would have to consider the mirror image flips, right?
But that is the other diagonal mirror image of the first matrix.
What diagonal?
From 0 to 3, 3, right? There is a diagonal.
Sure, I see what you're saying. Okay.
0, 0 to 2, 2. I'm sorry. So the third matrix is written from the second matrix from 90 to 92 is.
Sure. I see what you're saying. Yeah, yes. If I actually drew, let me see if I can. I think I can mark using a pen. So if I actually draw this diagonal, right? I don't know if you're actually watching on the screen share, you'll see it. If not, you won't. But if I
screen, I'm sorry.
There is also a screen share, Anusha, that you can see. Probably you're too high tech.
Yeah, I can see it's in that the conference call you joined. If you have joined with the phone, then probably you won't. But if
you're joined with the phone, right? So what you can do, Anusha, is that I think there is a link in the wall thing. If you go to I think there is no good way to do it. There is if you go to the free conference call wall/ST skills, there's a link I just pasted in QotD discussion. But then you have to go there and hit join.
Join on
just that will help you see the thing. You can just join as a guest. You don't have to sign in. It'll ask you to, but you can always skip it. But anyway, so here's like if I do it this diagonal, right, that is the same as this one. So, but you can probably think of it as multiple diagonals. And instead, the way I was looking at it was essentially a mirror image on this axis, a mirror image on this axis. That gives me 2 of them, and then both axes. That gives me this, which is most likely a mirror image across. There's a mirror image across this axis, which is different. So there are different combinations of it. So the way I was thinking about this was that you will essentially end up with 4 rotations total. Given the location, you have 4 rotations, and for each of the rotations, you have like 3 additional mirror images, right? In total, there are 4 rotations, and in total, there are 4 mirror images. In total, there are 4 flip states. So there are totally 15 states that you have, and one of them is the original state. So theoretically, you should see 15 different combinations, not just 3 plus 3, right? Anyway.
Shouldn't that be 3 rotations and 3 mirror images?
What's that again?
The line number 100. You said 4 rotations.
It is 4 rotations. There are totally 4 rotations in all, right? There are 4 states. If you just take the original state, start from the original state, you can rotate it and have it in 4 different ways, including the original.
Yeah. Okay. Yeah, that makes sense.
And then including the original, there are 4 mirror images, right?
1, 2, including the original, yeah.
So that means there are 16 different practical states. So you just have to compare. So given anything, you have to compare it with, so there are 16 different ways that are equivalent ones. So as long as the second board is equivalent of this, you're good to go, right?
So that sounds like 16n squared.
Well, it's a 3 by 3 matrix, so I'm not going to start looking at that. That's one. But one optimization you can actually do is always do check the number of X's and number of O's that you have. Only if they are same between the 2 boards, you can actually start doing the other calculations. I mean, if there are 2 X's in one and 3 O's in the other, in the same, and then the other one has like 3 X's and 2 O's or whatever, the opposite, right? There's no point in doing any more comparisons. Like the rotation is not going to give you any magical result. So that is one way of looking at it, and then the rotations actually help you in some shape or form, and you just keep going with it. And as you're comparing, the moment it actually fails any comparison, you can actually bail out. Right?
Yeah, makes sense.
Awesome. And there's also a slightly smarter way of doing it, which is that the rotation actually makes it go in only specific locations. So multiple combinations of rotations and mirror images will keep the 1,1 X in the same place, like the 0,0, right? Top left X will remain in the same place in different types of rotations and mirror images. Like for example, 86, this 1,1 thing, which I'm going to make it as a little x, remains the same in 94 top X. So as you're comparing, right, you can actually see if this location is the same. If it's not the same, then you can actually eliminate a lot of the combinations. You don't have to check that anymore.
Interesting.
It's a little, you can be a little smarter at it, but that's about it. So this question is not as easy as it sounds. I mean, I think people took it very lightly when I ran this. We were actually thinking of there's a lot more than just what is obviously, like, you know, that's evident to you. You can just look at it, you think it's super simple, but it's not. Okay, so challenge yourself. That will be the message there. Okay. Any questions so far?
Yeah, not from my side.
All right, super good. So let's go to the last one. How many of you actually picked the question name? Like, why is it called? Why is it Jew Stevens Counting?
It's just Steven. You've spoiled it.
It's just a wordplay. Sorry, me and my poor jokes at this point. So yes, I don't know if you picked it directly or probably someone you saw that in the comments somewhere afterwards.
Yeah,
I think. So how do you do this? What's the way to do it? So one of the things I heard was, and I wanted to see if you actually like it. So it was actually to go from like a Jew Steven to normal. All you had to do was actually Jew Steven divided by 2 is normal. Does that work?
No.
What do you mean? 0 by 2, 2 by 2, 4 by 2, 8 by 2. So far so good. 10 by 2, 12 by 2. It's all good, right? What's the problem?
There is no 10.
Because Zeus Steven, normal 34 Zeus Steven was, let's say, 228, and if you divide that by 2, it becomes 128, which is not correct.
Okay. Why is it not correct? Where does it break down? So just because it actually works for like a fraction of the numbers, you can't just assume that it's going to be like that forever, right?
Yeah.
In fact, it's only true for the first few, right? I'm just trying to see if I can pull up I had computed this. So if you look at this, right?
Yeah, if it's less than
that's
10,
all it
then
works for. That's all it works for, because 5 is what?
20.
It's 20, it's not 10. Right? It breaks down here already, and then it breaks down after that, big time. So how would you go about solving this? This is actually a question that you must have done before. It's just like I think it's the question is called like the Chinese counting system, where apparently people don't like the number 4 in China, so they actually go counting from 1, 2, 3. They skip 4 and they call it 5, 6, 7, and so on. And after 39, they don't like 40, so they actually go 50 completely. They skip all the way from 40 to 49, and then they go 50, and then that's it. So then the whole idea is that how do you map? This is like how they number their floors. It seems like I've not been to China, so I don't know whether this is really true or not. But that's apparently the interview question goes that how do you write a function that maps between Chinese floors and regular floors? Not a whole lot different from this one.
I mean, one naive way will be to kind of, keep computing Zeus Stevens number, and if it matches, then whatever normal number, transform that to, you return that number.
Hey, are you guys there?
Yes.
Yeah, hello?
Okay, sorry, I think what happened was, I don't know what happened, my phone just died.
Oh.
Okay, so I don't know what part of it did you hear. So I was actually asking the question of saying, how would it actually work if you had numbers from 0? If instead of all the digits, right? So if you had just zeros and ones, right? How would it work?
Binary.
So what is the next one? The special, it becomes
1 0.
1 0 and so on, right? So if I actually were to, so actually speaking, Steven is nothing but a base 5 system.
Yes.
That's about it, right?
Yes.
And then in addition to, so in a base 5 system, you use all the digits from 0 to 4. Here, you're actually using, instead of using 0 to 4, you're actually mapping the digits to this. 0 still remains 0, 1 becomes 2, and so on. So essentially, you still have to do the multiply and division by 2 to actually do the mapping. But you, instead of actually just doing just division, you will be treating this as a base 5 system, right?
Yes.
So pretty straightforward question. I don't know, was it very intuitive when you looked at it, or did you actually have to take some time to think through this?
I took some time.
Yeah, the question looked kind of pretty straightforward, but yeah, I didn't thought about the base system, right?
So
Yeah,
one of the recommended solutions, or not recommended, one of the solutions suggested was that you add a number, like add 1 to the number, and if it is invalid, like for example, if it has even a single odd digit, you discard that number and add 1 more to it, and you just keep going.
Yeah, that's what I did. I ran the counter, and whenever I found an invalid number, I would just keep on counting.
Yeah,
that works. That works. It gives the answer, but look at the time complexity of your operation.
I know.
Yeah.
This should have been a log n operation, right? Given the number, you're actually just extracting the base 5 digits and you're just using them, right?
Yeah.
So anyway, so that's how that's like, it's a very straightforward, simple question, but it's just it sounds like just do a division by 2 and it'll work. But then, what if I had changed the question to say, what if it's like just even excluding 6? What does that become? Like you can only use 0, 2, 4, and 8. That's it.
Base 4.
This becomes a base 4 system. Pretty straightforward. You still have to do base 4 and mapping, but here the mapping is not just multiplied by 2. What is the mapping here?
You'll have to use a hash table. 0, 0, 1 to 1.
It's actually 2 per D.
Yeah. Okay. Yeah.
It's just a pattern. Not that it makes a difference. You're right. After a point of time, I'm just going to go, you know what, chuck it. I'm just going to go do mapping. Use as a hash map or a direct, like, you know, if A then B kind of a mapping, right?
Yes.
Yeah. So that's good. So yeah. So anyway, what do you guys think? What do you guys think of the questions? Do you think it's is it something that makes you think? Is it not hard enough?
No, I thought those are fun questions.
No, so I think it's
Yeah,
so I think it's hard.
Especially the second one was super hard.
Yeah, Pam, go ahead.
So I think it's hard enough. Well, so I still don't understand how we convert from 0 normal to Steven to Steven number. What is the rule?
It's a base 5 system. So what you need to do is, if you have a number like say 123 in base 10, I'm typing in 121, right? What is the number in base 5? Do you know that? How do you do that first?
Well, so the first time I multiply to 2. Like 1.
No. First thing, if for a base number, if you divide by mod 5 will give you the remainder, divided by 5 will give you the quotient, and you keep repeatedly doing that. So mod 5 is actually 3, correct? 123 mod 5 is 123 mod 5 is 3, right?
Yeah.
123 modified 3.
Right? And what is the remainder? Remainder is 24, correct?
Yeah.
And
Then what is it? It's 4 and
4.
4. And then it's 4 and 0. So essentially, 123 in base 10 is actually 443 in base 5, correct?
Can you write it down?
Yeah, 121. I am in line number 121.
121. Oh, I haven't seen it. Let me give me what. 121. Hold on. Because I only see line 116, so I don't see anything.
Oh, just refresh the page. Just refresh your page. You might have gotten disconnected.
Oh, okay.
Do you see it?
1 sec. Hold on 1 second. What seconds?
Yeah, take your time.
Yeah.
I can edit a little bit.
Yeah, please. Yes, thank you. That will help. Are you there?
I cannot connect it anymore. It just says that the site cannot be reached.
Interesting.
I don't know why.
That's okay. So why don't we do this? I'm going to copy this and I'm going to paste it to you in the thing, right? So I pasted it in Slack.
Oh yeah.
Okay.
Yeah.
All right. So thank you, Manish. I think that's helpful. So now what we have is so what we've done here is that the first line is what is 123 in base 10. To convert it to base 5, first you do is you mod 5. So when you take a remainder after you divide by 5, you are left with 3, right?
Mm-hmm.
And then you divide it by 5 to get a quotient, and the quotient is 24.
4.
Correct?
Okay.
Then you again divide it by 5. Mod 5, divide 5. You keep doing that. And you get 443 as the base 5. So 123 in base 10 is 443 in base 5. Make sense?
Yes.
So now that you have 443 in base 5, you need to map it to, so base 5 goes from 0 all the way to 4. So 0, 1, 2, 3 and 4 are the elements in base 5. In the just even system, it is actually 0, 2, 4, 6 and 8. So you need to map 443 to just even system, so that becomes 886. So the 123rd number in the just even system is actually 886. Make sense?
Yes. Yeah.
Or you can multiply by 2, isn't it?
Yeah, that's multiply the 443 by 2, right? Yeah, you can do that because that becomes easy. So that's very cheeky, but it's just a mapping. So that works. And I don't know if you saw the other one where I said, what if it is just even but not 6, right? Then we heard that it's base 4, which makes sense. But then after base 4, how would you do the mapping? If 0, 1 and 2 and 3, if that maps to 0, 2, 4 and 8, How would you do the mapping? So you can always use a hash map.
Yeah, we can use that kind of mapping.
But in this case, it's actually 2 power d.
Yeah, that's right.
It's just a little cheeky, not something that I'm expecting people to use or figure out.
Yeah. With
Right?
the base 5, it's like multiplied by d, and in this one, it's more like 2 to the power d. Yeah.
Yes, it's d times 2, and yeah. Anyway, so that's good. So I think I'd like to stop this session here, and what we'll do is just want to hang around, have a little bit more conversation and feedback about what we have. Definitely looking forward to. Did I miss something? Actually, you're right. Actually, Arun's right. It is 1248, not 2 per d. I was just looking at the 2, 4, and 8. You're right. Sorry, I might miss. It's not 2 per d. 2, 4, 8 makes sense, but not 0.
Yeah. I guess we can make a little one line, if it's 0, then return this.
Come on. Then you can also have one more if, which is if it's 1, then return 2. No. I'll just use the mapping. You're right.
Yeah. That's it.
Awesome. So thanks. So what I want to do is get some feedback about the process and how this is working. I'm actually I like this session primarily because I think the limited number of people also made it a lot more easier and participatory. So I'd like to keep this going. Let's figure out how to make this happen. So I'm going to stop the recording and then we can continue our chat. All right. Thanks, everyone.
Okay.